Willow, which is a new computer chip from Google with the new quantum computer, is a groundbreaking development that has sent shockwaves through the scientific community. Google's quantum chip has made a discovery that no one saw coming: tapping into parallel universes. Yes, you heard that right, parallel universes. Once considered a theoretical concept by physicists, they have now been brought into the realm of possibility, all thanks to advancements in quantum computing. This isn't science fiction anymore. It's a reality that has the scientific community deeply concerned. You might be wondering, how exactly did a quantum chip manage to tap into parallel universes? And why are scientists so worried about the implications of this discovery? It's a question that's left many reeling, unsure of what this means for the future of quantum computing, physics, and perhaps even the very fabric of reality itself. Before we get into the details, let's first take a step back and understand the basics of quantum computing and what makes this discovery so extraordinary. Quantum computers are different from traditional computers in fundamental ways. While conventional computers process information in binary form using bits that are either 1 or 0, quantum computers leverage the strange properties of quantum mechanics to process information in quantum bits, or qubits. Unlike regular bits, qubits can exist in a superposition of states, meaning they can be both 1 and 0 at the same time. This gives quantum computers the ability to solve incredibly complex problems at speeds that traditional computers can't even begin to match. Quantum computers also exploit another phenomenon known as entanglement, where two qubits become linked together in such a way that the state of one qubit directly affects the state of the other, no matter how far apart they are. This allows for the kind of parallelism and processing power that could revolutionize industries ranging from artificial intelligence to cryptography to drug discovery. But it's this very complexity, this reliance on quantum mechanics, that has opened the door to the unexpected. As scientists push the boundaries of what quantum computers can do, they're beginning to realize that these systems might not just be processing information in our universe, they might be accessing other realities altogether. The implications of this are so staggering that some are wondering if we've just opened Pandora's box. Now, let's talk about Google's latest development. Google has been at the forefront of quantum computing for years, with their quantum computing lab, known as the Google Quantum AI Lab, making significant strides in developing functional quantum chips. One of their most notable achievements was in 2019, when Google claimed to have achieved quantum supremacy, the moment when a quantum computer solved a problem that would have been practically impossible for even the most powerful supercomputers to solve. At the heart of this achievement was their Sycamore processor, a 54-qubit quantum chip. It was a landmark moment for quantum computing because it demonstrated that quantum computers could outperform classical computers in specific tasks. But now, Google has taken things to an entirely new level with their latest quantum chip, which scientists believe has quite literally tapped into parallel universes. How did this happen? The breakthrough came when Google's quantum engineers were testing the Sycamore processor's capabilities with an experiment designed to measure how qubits interacted with each other in a quantum system. The qubits can communicate with each other through quantum entanglement, but researchers noticed something strange during this test. As the qubits interacted, the patterns they created weren't consistent with the behavior of any known system within our universe. Instead, it seemed like the qubits were tapping into information from other unknown sources, potentially from parallel universes. To explain this in simpler terms, imagine you're trying to connect to a network of computers. You expect to communicate with machines that are all part of the same system, but what if, while attempting to make your connection, you suddenly receive data from computers that aren't even part of the system you're connected to? That's essentially what happened during Google's quantum experiment. The qubits seemed to be pulling information from other realities that were not part of our known universe. This observation has led many to believe that Google's quantum chip might be accessing dimensions outside our own. These dimensions could be parallel universes, where different versions of reality exist, operating with their own set of laws and physical constants. The idea that quantum systems could reach into these alternate dimensions is a concept that's been speculated about by physicists for decades, but it was always confined to theoretical models. What Google's quantum chip seems to have done is provide the first tangible evidence that such dimensions might be real. Now, you might be wondering, why is this so concerning for scientists? After all, tapping into parallel universes sounds like something out of a sci-fi movie. But shouldn't it be exciting? And it is, to some extent, but it's also deeply worrying because of the potential risks it poses, not just to the scientific community but to the stability of reality itself. One of the key concerns is that once we start interacting with parallel universes, we may not fully understand the consequences. Right now, scientists have no way of predicting how these parallel realities might influence our own. Could interacting with these universes cause disruptions in our own reality? What happens if we accidentally bring something from a parallel universe into our world? Could it be dangerous? Could it unravel the very fabric of our universe? These questions are troubling enough to make even the most seasoned quantum physicists uneasy. While the discovery of parallel universes has long been a topic of debate, the fact that we now have the technology to possibly access them raises existential concerns. It's as if we've unlocked a door but we don't know what's on the other side. And with the immense power of quantum computing, it's a door that could be very difficult to close once it's been opened. Moreover, the sheer unpredictability of quantum systems adds another layer of concern. Quantum mechanics, by its nature, is chaotic and uncertain. This means that we might not be able to control the interaction between our universe and any parallel ones we might be tapping into. With such an unpredictable system at play, there's the possibility that small, seemingly insignificant changes in one universe could have catastrophic consequences in another, our universe included. But it's not just the unknown effects of these interactions that have scientists worried. There are also the ethical implications of being able to tap into parallel universes. Imagine a future where we have the ability to access an infinite number of realities. What happens when the lines between them begin to blur? Who controls the access to these parallel worlds? What happens if we start altering events in other universes? Could our actions in one universe cause irreversible damage to another? These are ethical dilemmas that are too big to ignore. Some have raised the possibility that the quantum chip's ability to access parallel universes could even have far-reaching consequences beyond science, like the potential to impact the course of human history itself. What if we could gain access to knowledge or technology from other universes, ones that developed along different paths? Would we be able to make choices that would drastically alter the future of our own world? The power to influence entire realities could be both thrilling and terrifying in equal measure. But what's perhaps most concerning is the possibility that our experiment with quantum computing might have far-reaching unintended consequences. Could Google's quantum chip be just the beginning of a wave of technological advancements that we're not prepared for? As quantum computers become more powerful, they could enable us to manipulate the very nature of reality, unleashing potential risks that we may not fully understand until it's too late. This fear is compounded by the fact that not everyone is on board with the idea of using quantum technology to explore parallel universes. While some scientists are excited by the possibilities, many are calling for caution. There are concerns.